Hello everyone and welcome. On today's video, I'd like us to talk about determinants. So by definition, they tell us that determinant is a number assigned to a square matrix in a certain way. Okay. So after I read that definition, the first thing that will come to my mind is this square matrix. So what if then you are dealing with a matrix that is not square? So if it's not square matrix, do we still have the determinant? So the answer will be that no. So the determinant will be undefined if it's not a square matrix. Okay, so determinants are only possible for square matrices. Now let's see if we have a matrix A, okay, with entries A, B, C, D, like that, and we want to find the determinant of matrix A. So if we want to find the determinant of matrix A, we have to keep in mind that this is how they're going to denote a determinant. So determinant of A, this is how they denote it, or they can denote it like this. Okay, so this is how they denote the determinant. So how do we find the determinant of matrix A? So we're gonna work on this general case. So we see that the determinant of matrix A is basically going to be A multiplied by D subtract B multiplied by C, just like that. Okay, so for a 2 by 2, say this one multiplied by that one minus this one multiplied by that one. Okay, so that is how you are going to find the determinant of a 2 by 2 matrix. Let's look at an example. Let's suppose matrix A had entries 2, -1, 4, and 3, just like that, and we want the determinant of A. So that determinant was going to be 2 by 3, we get 6, then minus 4 by -1, it's -4. So 6 minus by -4, that will give us 6 plus 4, which is 10. So the determinant of this matrix is basically equal to 10. Okay, so let's look at another example. Let's suppose you have a matrix B with entries 6, 1, -1, 2. So the determinant of that matrix will be 6 by 2 is 12 minus -1 by 1, that will still be -1. So minus by -1, that will give us 12 plus 1, which is 13. So the determinant of matrix B is 13. So you can see basically that finding the determinant of a 2 by 2 matrix is pretty easy. Okay, so on this one I used this notation, how they denote the determinant, and on this second example I used this. So if they give you a question where they're asking, you see they're having absolute of a matrix like that, that is basically asking for a determinant, or they can put it this way. Okay, so yeah, now let's dive into if we're having a 3 by 3 matrix. Let's suppose A is a 3 by 3 matrix, okay, with entries A, B, C, D, E, F, G, H, I, like that. Okay, so now we want to find the determinant of this matrix. Okay, so if we are looking for the determinant of matrix A, how are we going to find that? We are going to say this entry here, A, multiplied by, we cancel the corresponding row and the corresponding column. So what remains is the minor E, F, H, I. Then minus it's going to say then minus B multiplied by we're going to cancel the respective row and column. So we're canceling this and that, remain with DF GI. So it's going to be DF GI, like that. Then plus C multiplied by, we cancel this and that, so you remain with D E G H, just like that. So that is how you will find a determinant of a 3 by 3. Okay, so let's look at an example. If we are to look at an example, let's suppose you have a matrix with entries We have matrix with entries 1 minus 1 2 0 4 0 1 minus 3 minus 2, just like that. So we want to find the determinant of matrix A. Okay, so in order for us to find the determinant of matrix A, we can use either any of the row or columns. I can use this row, that row, that row, or I can use this column, this one, or that one. At the end of the day, the determinant is going to be the same. Okay, so I'll show you guys using the first row and also using the second row, so you can see that the determinant will be the same either way. So if I'm using the first row, I'm gonna say 1 multiplied by, we cancel the row and the column, the respective matrix that is going to remain there. The minor is 4 0 minus 3 minus 2, like that. Then I say minus, then we have minus 1. Okay, so basically this signs, how I go about them is that I have plus minus plus minus plus minus plus minus plus. Okay, then I use -1 to the power I plus j. So for those who are confused, where are the signs coming from? So it's -1 to the power I plus j, where I represents rows and j represent column. Okay, so if we are in row 1, like here, we are in row 1, we are in row 1, column 1. That means I and j are both equal to 1. So 1 plus 1 is 2, then -1 to the power 2, that will be positive. That's why for the first one, we have a positive. Then when we come to the second one, we are still in row 1, but now in column 2. So I is 1, but j is changing to be 2. So 1 plus 2 will give us 3. So -1 to the power 3, that will give us -1. So that is where this negative is coming from. Just like that. If we are looking for this sign here, this one is on row 3, column 2. So that means I is 3 and j is 2. Okay, so that gives us a power of 5. So -1 to the power 5 is going to give us negative. So that is how you get the signs. Okay, fine. Let's continue. Then we're going to multiply it. We are canceling the column and the row. What remains is 0 0 1 minus 2. So 0 0 1 minus 2, just like that. Then the last one, we say plus 2, we take that sign, plus 2 multiplied by, we cancel this and that, we're gonna remain with 0 4 1 minus 3. 0 4 1 minus 3, just like that. So let's quickly simplify. What are we gonna get? 4 by minus 2, that is minus 8. Then that will just give us plus 0. Then minus by minus, that will give us a plus. Then here we're gonna get 0. This by that is 0, even this by that is also 0. So yeah, this whole thing gives us 0. Then plus 2 into 0 by that is 0. Then minus 1 by 4, we get 4. Okay, so if we simplify that, here we're getting -8. This one is gonna go away. Then 2 by minus 4, that is -8 again. So the determinant is minus 16. So we know the determinant of matrix A is minus 16. We got that using the first row. Okay, we were using the first row. What if we use the second row? I said earlier on that if we use the second row, we're still supposed to get the same answer. Okay, so now I'm gonna find the determinant of A using second row. So yeah, they can ask you guys to use second row. I find the determinant using second row, third row, first column, second column. Just know what they mean is that you have to use this column to find the determinant, and you also have to keep in mind your signs. Okay, so yeah, let's dive into it and see how we're gonna solve that determinant using the second row. Okay, so using the second row, I'm basically taking advantage of zeros. So if I was in a test, I was gonna right away go to use second row, because these zeros are gonna annihilate things, then make my work much easier and quick to get to the answer. Okay, so the first one is 0 0 goes with this negative sign. So negative of 0, that 0 must be multiplied with. We cancel this row and that column. What remains is minus 1, 2, minus 3, minus 2. So you remain with minus 1, 2, minus 3, minus 2. Okay, so this whole thing we already know mathematically anything by 0 is just gonna give 0. So I'm just writing it down for those who might be new to this determinant thing, so they can follow up with us. Then for the second one, I'm gonna use plus. Okay, so it's plus 4 multiplied by we cancel the respective row and column, so we remain with 1, 2, 1 minus 2. Okay, so it's 1, 2, 1 minus 2, like that. Then the last one is gonna go with the positive. It's gonna go with this negative. We are on this row, so it's gonna go with this negative. So it's minus 0 by, we cancel the colon and the row, we get 1 minus 1, 1 minus 3. So what remains there is 1 minus 1, 1 minus 3, like that. So when we simplify, this one gives us 0 and this one gives us plus 4 into 1 multiplied by minus 2, we get minus 2, and 1 multiplied by 2, we get minus 2 again, like that. Okay, then here we're gonna just get plus 0 again. So minus 2 minus 2, that is minus 4. So 4 by minus 4, it gives us minus 16. So we see that even from using row 2, we still get the same determinant. At first we used row 1, we got minus 16. Now we used row 2, we still got minus 16. So that is basically the idea of how you find the determinant of a 3 by 3 matrix. Okay, so now let's get into the tricks of how you can go about determinants. Let me just use a different letter. Let me use B, because people have a tendency of thinking that always they will give you a matrix A. Nah, they can give you any letter. They can choose T, M. It's up to them. Okay, so now let's suppose you have a matrix B with the entries 1, 2, minus 6. Then all other entries here are zeros. Like, yeah, we are basically having a triangular matrix, an upper triangular matrix. Let's have an upper triangular matrix like that. So in order for us to find the determinant of this matrix, we can do it in a traditional way. But if you have a diagonal like this one, and below that diagonal is entries of 0, or suppose sometimes they can be up there, the zeros, the entries can be up here. Okay, so if you have zeros there, the determinant is just simply the product of the diagonal. Do not confuse this with the trace. Remember, on traces we were adding. Here we are doing a product, and we expect that to give us the determinant. Okay, so 1 by 2 is 2, 2 by minus 6, that is minus 12. So I have found the determinant of this matrix just like that, by taking the product of the diagonal. Keep in mind that that is only possible if below the diagonal there are zeros, or if you had a matrix C where now let's just say okay, I can use a transpose because it will still give the same determinant. Let me just say you have matrix C with the entries 1, 2, minus 4. Let me just say 1, 0. I want 0 there and another 0 here, and I'll want another 0 there. Then let me say here maybe it's minus 2, then here it's 3, then here can be minus 1, 4, 7, like that. So you see now, instead it's no longer an upper triangular matrix, but it's a lower triangular matrix. Okay, yeah, for as long as you have these zeros here, it's basically more likely in triangular form, but I wouldn't like to say that. However, let's just stick to upper and lower triangular matrix. Yeah, so since this all entries here are zeros, like here we saw all the entries below the diagonal were zeros, but in this case all the entries above the diagonal are zeros. That means the determinant of matrix C is just going to be 1 by 3 by minus 2, like that. So that is 1 by 3 is going to be 3 by minus 2 minus 6. Okay, so that is one thing you have to keep in mind. If you were, you can feel free to pause the video and try the traditional way of how we find what you call the determinant without taking the product of the diagonal, and see if ever you're going to get the same answers, negative 6 for C and negative 12 for matrix B. Yeah, feel free to try that. Okay, so that is one thing that you can keep in mind and use next time. So now let's go into the properties of determinants. So there are properties when we are dealing with determinants. Okay, so determinants have properties. Let's say you have a matrix A with the entries -1, 2, 4, 3, 1, -2, 0, -3, -4, like that. Okay, so how the properties work, the first one, they will tell you, actually this is the one that you have to know. They won't tell you, but from the matrix you will see maybe this is what they will have done. If two rows in A are added together to produce B, new matrix B, okay, then determinant of A is the same as determinant of B. So let's do that and see if this statement is true. Let's add two rows. I like to add two rows where I'm only affecting row 2. So I can say row 1 plus row 2 to get a new matrix B. Okay, so that matrix B is going to be what? Since I'm only affecting row 2, that means row 1 and row 3 are still going to be the same. So you're going to have -1, 2, 4, and the last row 0, -3, -4, like that. Okay, so now let's add the things. So we have 3 minus 1, that is going to give us 2. Then 1 plus 2, that is going to be 3. Then -2 plus 4, that is going to be 2. Just like that. Okay, so we want to show that this statement is true. Let's find the determinant of matrix A and see if ever is going to be the same as the determinant of matrix B that is produced after we add two rows in matrix A. Okay, so now the determinant of matrix A, we know how to go about it. It is pretty easy. So in this case, I'm gonna use this column here, the first column, because of it has an entry of 0. I know at some point there is something that is going to get away because of that 0 there. So yeah, I'm basically making my life more easier. Okay, so before I do that, let's not forget the signs, since if we get wrong with the signs, the determinant that we're gonna get is not gonna be correct. So it's plus minus plus minus plus minus plus minus plus, just like that. So those are the signs. Okay, so since I'm working on this column, I also have to work on this column of signs. So the first one goes with plus, the second one goes with negative, the third one goes with plus again. Okay, so -1 goes with plus, 3 goes with minus, 0 goes with plus, like that. So -1 is going to be multiplied by we cancel this and that, will remain with 1 minus 2 and -3 -4, just like that. Okay, then we come to this one, we say minus, this negative is coming from the signs there, then -3 multiplied by, we cancel the respective row and column, we remain with 2, 4 -3 2, 4 -3 -4, like that. Then the last one is going to be plus 0. Yeah, 0, we're going to cancel this one and that one, then we remain with 2, 4 1 -2. Then 0 is going to be multiplied with 2, 4 1 -2. I didn't want to waste time writing this, but however, yeah, let's just do it. If there was someone who was not following, I'm pretty sure now they see what we are doing here. So we're going to have negative of 1 by -4, that is -4. Then 3 by -3 by -2, that is -6. But then we are still subtracting. Yeah, it's gonna be positive, but we are still subtracting according to the formula. Then we have -3. Then we have -3 multiply by 2 by -4, that is -8. then minus 3 by 4, that is going to be plus 12. Then this one is going to give us 0 there. So we don't care about it that much. So when we solve this, what do we get? We get 10. Then here, 8 minus 8 plus 4, that is going to give us a 4. Then by 3, that is minus 12. So the determinant is basically equal to minus 2. So we want to see that also the determinant of matrix B must be minus 2, since this statement tells us the determinant of A must be equal to the determinant of B. Okay, so let's go and then calculate the determinant of B now. So the determinant of matrix B, we see that yeah, we can also use this first column because we are taking advantage of the 0 there, okay, to make our life more easier. So we're gonna have minus 1 multiplied by, we cancel this one and that one, so it's basically multiplied by minus 12, then plus 6, then minus 2 multiplied by we cancel this and that, so it's basically minus 8, then plus 12, just like that. Then this 0 is gonna make everything 0 there. Then B, the determinant of B will be minus 12 plus 6, that is minus 6, then multiply by the negative, that is going to be 6. Then here minus 8 plus 12, that is going to give us 4 multiplied by minus 2, that is going to be minus 8. Then basically here we get minus 2. So we see that this statement is true, since we get that the determinant of A is equal to the determinant of B, and they are both equal to minus 2. Okay, so that property is true. So you must know this property by heart. Okay, so the other property that we have is, if I'm still gonna use matrix A as an example. Okay, I'm not gonna write different matrices, so I'm just gonna explain all the properties using this matrix. So the other one says that if 2 rows in A are interchanged to produce B, then determinant of A is equal to minus determinant of B, just like that. Okay, so now what we have to do is to take 2 rows and interchange them from this matrix to produce B. Then after doing that, we have to find that the determinant of A is negative the determinant of B. Since we know already that the determinant of matrix A is negative 2, then we expect that now the determinant of matrix B must be 2. Okay, so let's first produce that matrix from interchanging. Okay, so to interchange row 1 and row 2. So if we are to interchange row 1 and row 2, we're going to start with 3, 1 minus 2. Okay, so we're starting with 3, 1 minus 2, then minus 1, 2, 4, then 0 minus 3 minus 4, just like that. So let's find the determinant of matrix B. Now we expect it to be 2, since we know the determinant of A is, it was negative 2 from the previous calculation. Now I'm gonna use the first column. Remember, I'm taking advantage of the 0 there. Okay, so it's going to be 3 multiplied by, I cancel this and that, I remain with 2 multiplied by minus 4, that is minus 8, then plus 12, then minus, so if I'm accounting for the signs there, it has to be negative. Okay, so this is from the sign, then I have negative 1, that will be plus 1 into, so I cancel this and that, get 1 by minus 4, then I get minus 6. Okay, so the determinant of B, if we simplify that, this is going to give us 3 by 4, then there we're going to get minus 10. 3 by 4, we know it's 12, minus 10, that is equal to 2. So basically the determinant of matrix B is 2. So we see that the determinant of A is equal to negative 2. So since we know that the determinant of B is 2, where there is 2, we can plug determinant of B like that. So you can have minus determinant of B. Okay, so this statement, it also holds, is true. So we see that if that is the case, when we are interchanging two row in a matrix to produce a new matrix, then the determinant of that matrix is negative, the determinant of the new matrix that is produced. Okay, so now let's look at the last property. Yeah, the last property is multiplying by a scale. Okay, so in fact, I'll leave that for you guys to try it yourself and see what is happening. Let me just quickly give you guys an example. Let's suppose we have a matrix A with entries A, B, C, X, Y, Z, 1, 2, 3, and we know that the determinant, let me write it down here. We know that the determinant of matrix A is basically minus 3. Okay, then from matrix A, there was produced a matrix B, where matrix B is 2, 4, 6, X, Y, Z, and A, B, C, just like that. Okay, so matrix B is like that. Then they say find the determinant of matrix B. Okay, so how are you gonna go about it? So you have to remember your properties in this case. Okay, so we see that from matrix A, what really happened on matrix B is that we had A, B, C on the first row and 1, 2, 3 on the last row. But on matrix B, A, B, C is on the last row. So basically they interchange the row. But then now the entries here are no longer 1, 2, 3, but they are 2, 4, 6. That means also this row, it has been multiplied by 2. 2 by 1 is 2, then 2 by 2 is 4, 2 by 3 is 6. Okay, so they multiply this row by a scale after interchanging. Okay, so now let's see. The determinant of B will basically, from the interchanging, we see this one now is there. Okay, and this one is on the first row. From interchanging, we know we expect a negative sign. Okay, then also the other thing that we were talking about now is that they multiplied the this row, this one, by 2. 2 by 1 is 2, 2 by 2 is 4. So if they multiply by 2 is basically a scalar, so you expect that determinant to be multiplied by 2 as well. Is that all that they did to obtain B? Yes, that is all. So that means the determinant of matrix B is minus 2 multiplied by the determinant of matrix A. So the determinant of matrix A is minus 3. So that will simplify to minus 2 by minus 3. That will be 6. So the determinant of matrix B will basically be equal to 6. Yeah, so now that will be all for the determinants. Thank you so much for watching and stay tuned.